welcome to the second talk of this 8th edition of the Legacy of Socrates. I am very glad to be hosting Barry O Sullivan. Barry is a Legacy PHP Web app specialist. Basically, he spent years and years working with Legacy PHP codebases. And in his opinion, it doesn't have to be painful. There are things you can do to ease the pain. And while delivering values, improve the quality, the maintainability of these code bases. Personally, I discovered him through the Legacy Code Rocks podcast. I'm going to drop that link into the chat, but it was a really good episode full of gems of wisdom. I really appreciated what Barry had to share. And so I reached out to him, and he accepted to craft a talk for you today, which is using test pane as a design guide. So let's dive into this. Barry, it's your turn to
talk. All right. Shouldn't have taken a drink of water just before that. So, hi there. My name is Barry O Sullivan, and as Nicholas said, I am a software engineer that specializes in legacy web applications. And I am here to talk to you about test pane and how it can be used to improve the design of your systems. So first off, we need to realize one thing. Pane is a form of feedback. It is telling us that something is wrong. It is also one of the most useful forms of feedback because it's so visceral. The problem is we don't know how to interpret this pane, so usually we just ignore it and plow ahead, cursing the previous developers and or our own lack of ability. But what I have to say is it does not have to be this way. So let's talk about the structure of the talk, what you can expect from this. First off, we are going to have an introduction to test pane, what I view test pane as and what the signifiers of it are. Then we're going to look at the types of pane, and what they're telling us. So we're going to look at some concrete examples and some potential patterns that we can use to alleviate it. Then the majority of this session will be looking through live examples of code. So I'll be applying some of the patterns and techniques that I discuss so that you can see the value of it. And then at the end, hopefully for 5 to 10 minutes, we'll have a Q&A session. So feel free to ask your questions in the chat throughout the talk, and we'll get to them at the end. Please note, there is a lag of about 40 seconds in the video, so getting your questions in earlier is better. So, what is test pane? Fairly obviously, this is the pain we feel when writing tests and having to interact with tests in any way. If you listen to your average developer, especially in the legacy space, they describe it as a necessary evil. It is always painful and irritating. The test code is harder to read than the code under test, and there's often more test code than actual production code. That alone is a major red flag and implies something is very wrong. Most of us view it as necessarily evil in the way that we have to add it so that we can verify our system works, so that we can have stable, iterative deployments. And or the manager is forcing us to do it because they know better. And by the way, you should always test. Testing is mandatory, I believe. But the problem is that most of us don't know how to interpret the pain of feedback. Sorry, the feedback of pain. So pain is a signal from a system that something is wrong. Physical pain is a sign that part of your body is damaged, and that should be addressed. We should rest and recuperate. Ignoring physical pain is rarely a good idea, especially it gets worse over time. Our bodies heal, but they're not magic. If you've got a damaged body part and it's painful, that means you should stop using it and let the body's recuperative process take over. Something similar happens with test code. Sadly, test code does not self-heal. And ignoring the pain is the norm when dealing with it. We rarely take the time to ask why testing is painful. What about our tests is causing pain? No, this lack of reflection means that our pain can only ever increase as we either ignore it or search for a panacea. Most of the time when I talk to developers about this, they're looking to solve their testing pain with a tool. They're looking for a silver bullet that they can just slide into their existing testing suite that will magically make everything better, be it a new mocking library, a new DB seeding library, or something that'll automatically refactor their code for them. I've yet to see any of these work. And that's usually because the pain points are domain specific and design specific. Your pain points are unique to you because of how you structured your application. Thankfully, there are recurring patterns. The pain is telling us exactly what's wrong and how to address it. We just need to learn how to listen. So I'm going to go through some common pain points I've seen. This is not a comprehensive list, but I think there is enough here that everyone who's watching will have some feel some discomfort when I list them, or perhaps some catharsis knowing that they are not alone in dealing with these patterns. Each one is a source of constant complaints and headaches to the people I talk to. So let's dive into some of these common pain points and see what they're telling us about our design. So here are some common patterns I've seen day to day when going through legacy code. Number one, the most obvious, can't read the test code. You look at the test code and you just go, what is this? I don't understand. You then spend a large chunk of your time just navigating the test code, trying to build up a mental model what's happening. And unless you're diligent and unless you're given the time, you will most likely give up at a partial model and try to figure out a way to ram your fix in, making the test code even worse as time goes on. It will progressively rot. Yeah, this is a major pain point. Another common one within messy test code, because you can't read it, is dependency bootstrapping chains. So you will have a dependency that's mocked that is then inserted and returned by another dependency that's mocked that then uses various other dependencies as givens for mocks, and the chain just goes on and on. So that the majority of your test code is this constant booting of dependencies that are mocked, so you're not even testing real behavior. Another favorite, and this one's quite simple. It's you have to use partial mocks. You are either partially mocking the class under test, or you are partially mocking a dependency that you're using in the test because you want certain parts of the code to actually be called, but then other parts of the code you don't want that to be called because either it's using infrastructure or it's doing something messy. Yeah, this one's a sure sign that something is wrong. Another favorite is excessive expect calls. You have loads of expect calls in your mocks. You can't tell whether they're actually there because they're bringing value or because the developers copy pasted a bunch of test code and didn't really understand what it's doing. It's very difficult to interpret. There's a lot of noise, so you don't know what's important, what isn't, and these expect calls are just getting in the way of you understanding it. Another common one, magic injection of objects and data. You have your code creating and injecting fake instances, mock instances, or just shoving in data in whatever way. And it's doing it in some, most likely if it's legacy, in some crazy ways. The most egregious example I've seen is somebody in PHP installed I think a PECL library that is it overrides the new keyword. So anywhere in your code where you call new and create an instance of a class, the test code is overriding that and injecting in a fake or a mock. Good luck interpreting that code and figuring out what's actually happening. And then finally, a classic, seeding database data everywhere. This one is one that we have all seen. It is one we are all guilty of doing at one point in our career, and it is a sure sign something is wrong with our design. Okay, so let's look at, well, first I want to say, I'm sure everyone here has experienced these in one form or another, and probably flinched when I mentioned a few of them. Some people are laughing, maybe out of awkwardness. I understand. But let's look at what each of these pain points are telling us and see what we can learn from them. So the first is the most common. The test code is impossible to read. It's messy, convoluted, and unexpressive. This is because the test is A, doing too much, B, focusing on details, not abstractions. The solution is simple. Refactor. Iterate on the test code until it's clear. This is the most crucial step in dealing with test pain, and it is the step that I see so few developers actually doing. In the TDD feedback loop of write our test, watch it fail, get it pass and refactor, we interpret refactor as our production code, and we have a tendency to leave the test code alone. Test code is real code and it needs to be maintained like production code. We need to refactor our test code and bring clarity to it. Now, if this seems you don't know how to do this, don't worry on it. I'll give an example, a concrete example of this later and show you what you can do. Next, we have the second, and it's the other most common pain point in web applications. Test seeds tons of data for even basic tests. They're slow, brittle, and also confusing. This is a sign that your database is deeply coupled to your application and your domain. You should move your DB test code into integrated tests that ensure your DB integrations work, and then use repositories in your unit tests and/or acceptance tests. You basically want to move that implementation detail out of the tests. Only the tests that are making sure your code can integrate with whatever the database engine is, like be it SQL, be it Mongo, et cetera, et cetera. Now, I just want to say integrated tests are different to integration tests. An integrated test is a test that just makes sure your code can integrate with another system, even if it's one that you control. Whereas integrated tests are making sure that lots of components can work together using real ones, usually using a database or something like that, an actual instance. Personally, I don't like them. They're a pain point, and I would suggest you avoid them. If you want to learn more about this, I'd watch some of the talks by JB Rainsberger. He's got a great one on integration tests or a scam. Okay, so then we move on to complicated dependency bootstrapping. And it's another awkward one. You have lots of code and concepts glued together, and then they need to call each other. So you have to create complicated chains of fakes and mocks in your tests, none of them actually testing behavior. What you're actually doing is double entry bookkeeping, like in accounting. You're just making sure that you are checking the chain that you have created in the code. This isn't bad in itself, but it's a sign that you have hidden concepts, side effects mixed in with behavior. What you should be doing is looking to extract these, test them once, and then inject test them once maybe into a factory or something, and then inject those into your objects as dependencies and use those. So you should be trying to isolate them, move them out of the messy object under test, and then give that a name. All right, so then we move on to something that's one I said I've seen a lot in legacy systems, magic injections of objects and data. This happens because the code was never written to be tested, and most of it was written without tests. So rather than refactor it, the developers did what we do best, figured out how to solve the problem. And we wrote magic code to inject in fakes and mocks, etc., often using static methods and various techniques. This one is insidious because it is masking pain, not alleviating it. What you should do is you should move towards smaller encapsulation boundaries and use dependency injection via the constructor. This will make testing easier and make the next design steps obvious. After that, we have partial mocks. Partial mocks are a sign that you have behavior and infrastructural code mixed together. Typically, infrastructure code that's painful to use under test, such as, for example, API calls. And that's not a spoiler for the code example that's coming later. So the solution there is to separate the abstractions from the details using your tests as a guide. And finally, excessive expect calls. This happens when you have lots of side effects, i.e. code that does something but returns nothing, mixed into your behavior. The solution here is to separate them. Have your behavior that figures out what to do and manipulates data, then your side effects in their own self-contained section. Side effects should happen at the end of behavioral chains, not in the middle of them. So this is just about giving you a hint about where you should move your code. Okay, so as I've kind of been hinting at up to now, the first thing we need to do is make the pain obvious, then isolate and identify it. This means we need to refactor our tests and bring clarity to them. We then use the express context to refactor our production code. We iterate on our test code and allow it to tell us the shape things should go. We're not telling it what it should be, we're letting it tell us. That's actually something I learned from Kent Beck. And I am eternally grateful for it because it made me realize I am not the person that is designing the code. I am more unearthing the design that's already there. So when we're doing this, there are actually two types of test pain. There's accidental or essential. And I learned this also from J.B. Rainsberger. So he calls that complication. And in this case, I'm viewing it as pain caused by complication. So essential pain is just the cost of doing business. The more code you have, the harder test will be to maintain. It's just the nature of any system that solves a problem. There's a certain level of complication that we just have to accept. Accidental pain is pain caused by poor design. This is the pain we have added accidentally, and it's pain that doesn't have to be there. This is the pain we should listen to when improving our designs. And this is actually fairly simple to do. We just need to refactor our tests. And here are our instruments for refactoring. This is how you make your tests tell you exactly what's wrong. This is how you refactor. So number one, simplest technique, lean on automatic refactoring tools. The tools will allow you to experiment and add clarity safely. You're able to create methods, you're able to extract variables, extract methods, extract classes. You're able to rename concepts on the fly. It just makes it much safer and less manual. Highly encourages. Then we move on to naming. Name your concepts explicitly. So this is an idea from Eric Evans of DDD fame. Be expressive, be explicit, and be awkward. Use awkward names. Make the pain visible in your test code. Group similar concepts together in the tests as well, so that you can see like with like. Put awkwardness next to awkwardness. Third, separation of concerns, encapsulation. You want to encapsulate the behavior, describe what you're doing, not how you're doing it. And this is in the test code. And to do that, I would suggest using given, when, and then. So this is a testing pattern from BDD. What you're saying is, given the system is in this state, when I perform this action, then I expect these outcomes. It makes your tests read like a story. So you should lean in this direction. So let's move on to the real stuff. We are going to look at some code and see what these techniques, how they can help, and what we can do to listen to the pain and unearth design patterns and concepts. I will say, all of these examples are real. They're real problems I've seen in the wild during my career. None of this is real code taken from people, but the problems they highlight are very real. So we're going to look at 3 examples. First, we're going to look at cleaning up complicated test code to gain clarity using the techniques on the previous slide. Then we're going to look at an example of DB seeding pain and how it can lead to separation of concerns. And finally, we're going to look at partial mocks that hide concepts and how then we can separate those concerns. So let's dive in. First off, we are going to start off at legibility. So this is what I would consider a standard controller test as seen in the wild for a legacy project. As you can see, it is seeding some data. It has a lot of setup code. It's enabling and setting feature data. It's creating spies and dependencies and overloading them. It's creating spies in multiple ways using one implementation here. Then it's creating partial mocks, setting up lots of expectations, and then injecting it. It's creating inputs, I think. From what we can see here, it's creating lots of examples. And it is making API calls to a controller with this data and also overriding it here. Now we're just getting past the bad calls. Now we get into make the call, then it's making a query to get data, asserting that certain things are true or false. Okay. So yeah, I expect everyone's able to follow this and knows exactly what's going on. No, not at all. First time I looked at this, I was completely lost. So what I did is I refactor it. So got to say, where would you even begin with this? Well, let's start small and use some of the techniques I described previously. We're going to do a given, when, then on a method, and we are going to apply, let's see, yeah, we're going to work on naming. Okay, so let's find one example that we're looking for. So let's go for which one? Okay, yes, we're going to go for test 200 OK. And first thing, it's very hard to tell that that is a 200 OK and not 2000 K. So I'm putting in an underscore there. And then do that so it just reads a little bit better. Okay, that's one. Okay, so first off, let us refactor. And we are going to extract method. We are going to give this a name. So let's go with, what is that behavior? Configure IDs are required. Okay, so this is given. IDs are not. So you'll notice it's find patterns here. I would always click yes, but in this example, it's going to cause the code to jump around the place and get lost. So we're not going to do that right now. So we'll just leave that as is. Then we have disable address confirm. We are going to do the exact same. And so that is given address confirmation is not required. Okay, I'm quite happy with that. Okay, then we have, it's creating an identity command. It is saying that it should never be called, and then it is injecting it. Okay, well, this is noise, and this is an implementation detail. So we're going to hide that. And what will we call that? Well, it's got an expectation in it. So this isn't a given, this is an expectation. So let's be very explicit and call this expect. And then it is the identity. We don't have to mention its command. The behavior, that's the implementation. So the behavior here is expect identity not to be created for here. Okay, great. Let's move down then. So we've got our API call. It is calling the controller, and it is passing in a shop ID and an input array. Okay, what do we want to do here? Well, I get the feeling that looking at the other tests, this part stays the same, these parts change. So what I'm going to do is extract these out into a variable. So we're going to call this, shop ID. And then we're going to call this, well, what is this? Well, the name's already pretty poor. So we're going to call this, it's actually a HTTP input. All right. And I've already switched back to camel case instead of snake case. We'll put that in there. Okay, that's all good. And then what we're going to do is give this a name. So what's the behavior? When identity is submitted. It says it's a post call. Okay, great. And then finally, at the end, we have calls where it is querying data and then checking assertions against it. So I would, just something I do here, I call these verification calls. So verify is a keyword I use that means it is querying into the system and then running assertions against it. So it's a sign that it's doing something it really shouldn't. And I like to use the verify keyword because it implies to me context of what's happening in the behavior without having to worry about the implementation details. And it's assigned to refactor it, potentially refactor it later. So let's do this. So first off, we'll refactor. And we're going to call this one, let's see, what is it doing? Is business false? Okay, well, it's verify shop is individual. Okay, great. And then we have these, which is assert that we got the expected first line and name, and we've got the owner. So we're expecting the shop address is the individual owner. Great, we're getting there. One thing I don't like, some messiness. Oh, and it's actually, that should not be assert. Because what we're going to do is, I actually want to make this a verify. I don't like that we're getting the result from a verify call. So what we're going to do is we're going to do a minor refactor here, which is we're going to remove this dependency. I'm going to go in here, get this. I'm going to shove it in there. So now we have made it so that the call itself is much cleaner, so that this reads basically like a sentence. This reads like a story. So that's small iterative steps that anyone can perform. Let's have a look at what this causes. So if I were to just check out this refactored branch, let's have a look at the end result. So scroll through. Our setup is basically just booting up the system. We have it saying that it's creating certain dependencies via make. So it's saying it's creating things, but not giving them any behavior. We then have a stage where it is giving behavior. So these are the givens that are assumed before any of these test cases run. And you can just read at a glance that the state of the system that we intended to be in. The 400 bad requests are a lot easier to read. We take an input array. We say we expect an exception. And then when it's called, that's what we expect. If we scroll down further, we can see into the 200s, given IDs are not required. When the identity is submitted, verify shop as individual. You can see that we're passing in these variables, and we're passing in the IDs, because these are the things that change. Input array, this changes, gets passed in. And if you just scroll through now, each of these test cases now reads like a story. They describe behavior, not implementation. And if we go down below, we'll see that we can see the implementation details. So then we move into the when, which is, first off, booting up the spy for injecting things into the controller via the magic I talked about earlier. So now that detail is hidden. It's making the API call, and then it's restoring the spies. We go down further, we have our factory methods. This is putting like with like. So you can see here that this is creating, first of all, lots of inputs with expressive names. Make business identity input, make HTTP input array with missing jurisdiction, because that's a special case. Make input array with missing ID. Make non-US business identity. And then we move into the makes for various styles, and you can have a partial mock here. But the key thing is that this detail is hidden. We then get into our givens. Some of the givens make database calls. Some of the givens are working with fakes and mocks. The key thing is that all of these details are now hidden. So that means all of these details are isolated and now can be easily changed and swapped out. So we've made it so that anyone that's reading it can see what the expected behavior is. We're describing it as a story, and then they can dig down into it. Okay, so let's go through this. What is this implying? What are the concepts that are being expressed here now that we've refactored? Let's look at what we could do. So, for example, any of the givens with DB seedings, like this. We could replace the internals of these with entities and fake repositories. Same with the verified methods. We could use fake repositories for that as well. That means now that we are no longer relying on database seeding. We have removed that pain, and we have expressed design concepts that were hidden. I would even use in-memory versions of this, so you don't have to mess around with mocking libraries. Why not keep it simple? What's next? Well, if we look at the make methods, if we scroll back up to those, should I say? If you look at the make methods, they're making for all different types of inputs. They're quite noisy, but they're all clearly linked to key behaviors. So they should probably be classes in their own right, well-named classes with independent tests and behavior. Then we could make the controller streamlined. It would call behavior on the sub-requests. This would be a classic example of tell, don't ask, and allows us to simplify our expectations and mocks. So this is the power of refactoring test code. It allows us to spot patterns and see the shapes of the concepts that exist in the code but are not yet expressed in the production code. We just need to iterate. And even without that, these tests are now legible by anyone. Junior, senior, doesn't matter. It allows us to explore the concepts in our code without having to touch production code as well. This is a safe place to iterate and try out names and try out awkward naming conventions and patterns and ideas. And it suggests patterns that will make our lives easier and future change possible. Um, and that's how powerful iterative refactoring is. Okay, so we have, I believe, 5 to 10 minutes before the Q&A section. So I am quickly going to go through the other examples, and I won't go into any depth, which I would love to, but time constraints. And also, as Nicholas said, this is something that I created specifically for this. So these kind of things happen. So let's move on to DB seeding. Okay, so what's happening here? We have an example of a test that is seeding too much data. Okay, so it's seeding 3 different types of table. Why? So if we dig into the behavior, we can see, but not very clearly, that it is changing data and then checking to see if an advisory card is displayed. This is a card that's shown to the user in the UI. So first, we are making sure that nothing is displayed. We're changing it to failed, and then we're making sure, oh, a card should be displayed now. Then we are storing it again, asserting that nothing changed. Then we're changing it to verified, and then asserting that nothing is displayed now. And then if we switch it back to failed, it inverts. So that's effectively what we're testing here. And you see that we're making queries. So what we have is a test that is coupled to the implementation details of 3 independent concepts. 2 of them are in the domain, 1 of them is the UI, and they all just happen to use a database for storage. But now that detail is muddied together. And the test is also doing way too much in a single method. Why is it doing this? So if we go in and we look at the type declaration for this, we will see, the concept under test is based on active record. The developer's job was to display a card every time it was saved. So what they did is, due to the nature of active record, this is how they opted to do it. So they overrode a protected method, record stored, and they create the classes on the fly. So they had to seed the data. It was the only way to test this method without injecting in the dependencies via test setter methods, which is a major red flag, by the way, major code smell. You should opt not to do that or try to avoid it if you can. So what is this test pane telling us? Our behavior is tightly coupled to our database implementation, and we should separate them. We need to separate behavior from technical details and move towards mocks and away from database seeding. So the first thing I did was refactored this using given when then, extracted out the multiple test cases, separate out the implementation details. And if we go into this, we can see we have 3 test cases. So a test that stores the ID, test that failure card is shown and failed, and then test that the failure card is address failure card on verification. So we're making sure that the expectations of the calls are made. And then we inject in an account finder and a card factory, so this data doesn't need to be seeded. And we have now created a verification code repository, which has this. So yeah, I went through, did the standard given when then expects to define behavior, and then I could refactor the internals and swap in the implementations down here. Yeah, and to verify the changes are made. So let's have a look at what that looks like internally now. Go in. It's still taking in the active record, but now it's passing in store. So this is a side effect. So we've hidden this side effect now, and we don't need that expectation in the in some of the behavioral code, or at least we've isolated that here. And then we have update the UI, and then we find the account. We then have a card factory that makes the card, and then we, based on the status, we figure out what we want to do. So yeah, we are now checking the behavior rather than the implementation details. The test for this behavior has absolutely nothing to do with the database anymore, which is exactly what we want. We're just dealing with the concepts at a higher level. Now, as some of you are probably mentioning or thinking right now, the repository really shouldn't be referencing UI concepts here. True. But in order for this to get, in order for me not to make too many changes, this is where I've gotten into. At least we have moved the pane elsewhere and have code that is easier to change. So we could move it to an event-driven UI system if needs be, with the repo broadcasting it with a record stored event, separate the concerns even further. But this test makes that incredibly easy to do. And then finally, we are going to look at the last one, which is partial mocks. So this is the final one, but it's one I've seen a lot. We have a test that is partially mocking the class under test, which is create user. It is mocking get credentials and make API call. It is setting a given behavior here for that and the make call. And then it sets the data and then it checks the result. So this is a fairly common pattern. Now, if we go into this, we'll see, oh, we're extending an abstract class again. And if we go into this, it's got loads of protected methods. We see, okay, this makes sense. It is actually this thing makes the API call itself internally. So it's got a load of API call stuff. It's checking config, all these kind of details that we do not want to touch in the test. So this is really getting in the way. This is a fairly common pattern where someone wants to add behavior to a class and they want to make it really easy to create a new version of the class and use it. So they've optimized for writing code, not reading and testing it. But in doing so, they have accidentally made it much harder to test, and that makes it harder to verify and creates pain for everyone that has to interact with it. I would call this cleverness, and it should be avoided at all costs. Clever code is hard to read, which makes it harder to test. It's almost like those concepts are coupled together now that I think about it. So I have been guilty of writing this type of code, so believe me when I say it should be avoided. I have tried to be clever and failed multiple times. So what is this test telling us? It's telling us that a core implementation detail is getting in the way and should be extracted into its own concept. We need to separate the concerns and apply the dependency inversion principle. I know, technical. So rather than having an abstraction, a request, coupled to an implementation detail, curl HTTP calls, we should couple the details to the abstraction. This is a fancy way of saying we should pass the request to something that makes the API calls. So you use all these words to make yourself sound smarter. So when actually it's very simple. So let's have a look at what it looks like when we separate them. Let's check out partial mux. Okay, so let's have a look at a create user test. Well, the create user test has become incredibly simple. It tests makes requests for service. We have an expected request. Then we say, when you make the request, assert that these are equal. So this is effectively saying, hey, if I give you this, you should output this. That's all the request needs. Same with, hey, and when you get this response, you should adapt it into this shape. That's all we need. We have our when method here. We have when request is made, when response is adapted. We have a factory method just to make the request. And then it makes the various expectation calls. So the test is incredibly easy to read. If we were to open up this request object, it implements an interface now. It has absolutely no details of anything. And we've made it so that it is a named object with these being passed in, so which means we could do validation here as well. So this has become a lot simpler. And let's look at the requester test. What does that look like? Well, we have moved all the messiness of the implementation details into here. We've extracted it out and made it much simpler. Now, one of the things that's interesting with this, the way I actually implemented this, is that I started with the create test, extracted out the concepts, and then inserted into the given when then method, swapping in the new implementation, and then reran the test to verify the behavior hadn't changed. And then once I was happy with that, I then split the test into two separate tests iteratively. And yeah, that's that. We could even test the HTTP client independently now, by the way. So if I go in here, you can see it's creating a mock of this. We could test it in an integrated test, as I mentioned earlier. This wasn't possible for. To do this, we would spin up a local HTTP endpoint with dummy endpoints, then ensure the client parses the response for each HTTP method. Easy. Well, I make it sound easy because I made this. But anyway, you get my point. Okay, so I think that is enough code example. I think we should move on to the questions. I would like to say thank you very much for listening to my talk. I hope you enjoyed. And now let's get to it.
And I would like to say thank you very much for doing that. I loved the example. I loved a couple times and very practical also.
Thank you very much.
Not everyone is probably doing PHP, but all of the examples are really readable and could be transferred to any kind of legacy code base you're dealing with, I guess.
Oh no, 100%. Especially like one of the things you tend to do with it is you migrate towards more object-oriented typed code. So basically, this is applicable. You're basically just making it better code. It doesn't matter what you're using, if Java, C Sharp, and also you're making the code more functional. So the same pattern works for, say, example, F Sharp.
Exactly. Okay, we have a couple of questions already, so let's jump in. The first question is, when do you start a method with verify and when do you start it with assert?
Okay, that's a good question. So you start it with assert when you are taking the direct output of the when statement. So what you're saying is that I've asked you to do some work, you have given me an output, now I want to assert that output is what I expect. So the idea is that you're saying flat out that this is based entirely on the behavior of what this is output. Now, you use verify when you are verifying that side effects happened. And this is typically, as I said, a sign that you're actually plugging into the heart of the system and asking a question of it that you couldn't get from the when. And this is usually a code smell. This is usually a sign that you have a hidden expectation there and that you're using a real version of a dependency when you should be using a mock.
Stellar. Perfect. The next question is actually from me. Do you have any advice on training your teammates to refactor test code and test code in particular? Because as you said, it's something most developers will forget.
Yeah. Okay. So first of all, you're going to have to get agreement from people that this is something that you want to do. You have to get consensus or buy-in from the team. Now, what I've done for this is that I've done pair programming sessions with people. I basically get them to bring me a piece of test code that they recently interacted with, felt a lot of pain with, and said that they were fighting. And then we go through it together, applying these iterative patterns just to express it, trying out different ideas, et cetera, et cetera. And then afterwards, we just review it, compare them side by side, and go, okay, now how would we make these changes? Once people see that the pain has gone away and they can now understand and that they can take iterative steps before that, I find that buy-in is a lot easier to get. Now,
Yeah,
it's not a guarantee because some people don't want to put that. Some people don't want to do it, but all you can do is give it your best shot and just try to show that things can be better. And as I said, focus on the pain.
exactly. And yes, like people may have a hard time seeing what you see, and so showing that to them, pairing is an excellent way of doing that. Thank you very much. Next question. What is your opinion on text fixtures? Your test file is really large now. Would you consider moving some of the test inputs and factor it into their own file, for instance?
That is a great question, and the answer is 100%. What I do is I like to keep them in the file for the examples I'm showing now, especially when I refactor towards clarity. But as is being spotted here, you should 100% extract those out into factory methods because you're going to notice that a lot of your code is going to have similar patterns and that repeating fixtures. So you should extract those out into factory methods, into builder methods. Builder, if you start doing permutations. The same with some of the verify calls, and the same with some of the expectations, and even some of the bootstrapping. Because the idea is that you will notice, it'll force you to notice recurring patterns in how dependencies are used and how data structures are created and the behavior is defined. And it makes it much easier then to reflect those patterns within your production code as well. Because you'll often find that that factory that you have just extracted, well, that's expressing a concept that's clearly in my production side, in my domain side. So I should express that. And then suddenly the two systems are feeding their feedback into each other. And then you start getting a very strong feedback loop that allows you to improve things. But yeah, 100% extract them out in classes.
Awesome. Then we have an interesting question, which is the make methods, don't they obfuscate what the test is doing? Since you have to jump around to see what the data looks like? What do you think about this?
True. You have to go around and figure out exactly how you're booting this thing up. But what you're trying to do is figure out, can I give a name to this that expresses the awkwardness of what this is doing? And if you find that the name isn't helping you understand it or doesn't become a shorthand, then yes, 100%, it is obfuscating and it's not actually helping. It turns out that that detail that you're looking for is important and it needs to be promoted upwards into, say, either a method or into a concept. As I said, the idea is that you're trying to simplify it like this so that it reads like a sentence, and then you're iterating through and trying to find the pain within that. What is getting in the way of me understanding this, and then promoting anything that's painful to something that's addressed at the same level. Because clearly, as you're saying, those details are important enough that they should be their own concept.
Yeah, that reminds me of we had recently Dr. Feline Hermans doing a talk here, and she published a book this year which is called The Programmer's Brain, and it's all about making code easier to read, and it's a fine balance between, you know, sometimes you have abstractions but they're not useful, they make it harder for you to understand what's going on, so you may inline these abstractions, and on the other way, when you have too much code, too much details, you're overwhelmed with all the information. So you're trying to extract, like Barry did that a lot, extract, and give good names so that you find the correct balance and you don't feel the need to move around, only to focus on the parts you really want to dig into.
Exactly, exactly, and that's as the person who asked the question had pointed out. If it's getting in the way and you constantly are having to jump around to the definition, that means you haven't given a name that is expressive, or it's doing too much and you need to extract it out into two or more concepts.
I'm gonna drop the link in the chat.
Great, great.
Okay, we are running out of time. Last question.
Okay.
What is your heuristic to know your mocks aren't mocking too much so that your test is only testing a happy path?
Okay,
Not
okay. So that's a difficult one. Realistically, there for that, as I said previously, you try to group chains of mocks together into a single given statement if you can. If it's bootstrapping a lot of things to perform something complicated and with makes and et cetera, try to isolate all that into a single given. What that's telling you is that, hey, this is a concept that this should be extracted out into its own class, and I should be trying to see if can I then extract that, figure out what are things that have expectations, so they should be mocks, and then what is the behavior within that, and then use real concepts, like for example, value objects or entities. But the idea is that this is effectively telling you that, hey, this is a grouped concept of things, and maybe they should be grouped together so that I can just use that elsewhere. And this is also useful if you apply this pattern across multiple tests. You'll start noticing repeating patterns in the givens. It's effectively screaming to you that there's a hidden object here.
Yeah, and also I would say incremental, like especially with existing legacy code, legacy test, you cannot make it perfect the first time. It takes practice, it takes some time. You see Barry here, for instance, he didn't have the time to cover everything. So the repository does some UI stuff. It's not perfect, but it's still better than it used to be. And like still ship value, meet the deadlines, but go in that direction. And then you will find out the missing concepts, stuff like that.
100%. And one thing I would like to say to people, a key thing I find with refactoring legacy test code is you're not just expressing concepts, you're also giving your brain concepts to latch onto and to try out. And what will happen is that after you read this test code and you refactor it, you'll go to sleep. You'll wake up the next day, look at the code. Those concepts are now foundational in your brain, and the next steps will be obvious to you. They will jump out of the code about what you should do, how you should move forward, what will get rid of the pain. So what you're doing is you're kind of, by even doing this process, you're priming your brain to spot patterns that'll make your job easier.
Awesome. Thank you very much for all of this. We're going to wrap up this, take a 10 minutes break, and then we will have Claire Sudbury talking about how not to make each other feel stupid, which is an interesting topic, I think.
That sounds
Thank
great.
you very much, Barry. Thank you for being here today.
An absolute pleasure, Nicholas, and thanks for having me. I hope people got value out of this.
I'm sure of it. All right, see you in 10.